Okay, so now we want to go over the summation properties shown here on the left. This is all part of learning how to work with sequences. And this is we're still talking about sequences because this is going to from I equals 1 to n, right? So a series is like infinite sum. So if you took you could turn you could turn a summation into a series by saying the limit as n goes to infinity of a summation. So we're still talking about sequences in this video, but when it comes to using summation properties like this, you can do that with a series as well, right? Because again, I mean, a series is the exact same thing as this, but just as n goes to infinity. Now, obviously, you need to be careful if you're dealing with a series. I'm not saying 100% every single thing we do in this video or everything you'll do with a summation going to a finite n, you can do with a series, but in general, yes, you can. Okay, so we know what this like a sub I is. This b sub I, that's a sequence, right? This a sub I is just an a sub n, but they took out the n and put a subscript I here for the summation. I can turn any a sub n into a summation by just putting it in this form. You see, and again, you could have a finite sum of a sequence where you go to some actual finite n, or an infinite sum of a sequence, which is called a series. And these properties are important because in the next video, when we do some examples, you'll see how you can use these properties to simplify a summation. Okay, and lastly, you can see all of these properties start at I is equal to 1. So the sequence starts at 1. But some of these don't change if you change from I is equal to 1 to any other start point. Some do, but if you need one or more of these properties converted to another start point other than 1, you could maybe do a Google search, but also you could intuitively just take a look at the property yourself. So for example, here, so let's write this out. I is equal to 1, you have C. I is equal to 2, you have C. I is equal to 3, C. All the way to C, even at n, it's just C again. Right? You did this n times 1 to n, so in C. If you started at I is equal to 0, okay, I is equal to 0, you have C. I is equal to 1, C. 2, C. All the way to C. Okay, but in this case, you have n plus 1 C's because you started with 0. If you started I is equal to -1, it'd be n plus 2 times C. If you started I is equal to 2, it would be n minus 1 times C. What about this property? Let's write this out. So we're going to write this out first. You have CA1 plus CA2 plus CA3 all the way to CAN. Okay, so you can factor out a C, and then what do you have? A1 plus A2 plus A3. You just have right? So what if I is equal to 0? You've got CA0 plus CA1 plus CA2 plus all the way to CAN. Factor out a C. Or no, you start at 0. Right? You factor out a C, you just have A0 plus A1 plus A2. So no matter what index you start with, you're just going to have C times that summation again. So this one is valid for any start point. Okay, let's take a look at this one. So writing out the summation, we've got it's 1 plus 2 plus 3 plus 4 plus n. Okay, so this is an arithmetic series, adding 1 each time. And if you watch the arithmetic series video, you can see how the summation formula is derived. So I imagine it's similar. Proving this is a similar process to that. So let's say this sum is equal to x. Okay, so x is equal to 1 plus 2 plus 3 plus 4 plus n. Okay, now x in descending order is n plus n minus 1 plus n minus 2 plus n minus 3 all the way to 1. Okay, now if we add these two equations, we get 2x. So you have n plus 1, and now n minus, or 2 plus n minus 1 is another n plus 1. 3 plus n minus 2 is another n plus 1. 4 plus n minus 3 is another n plus 1. And then at the end is n plus 1. Okay, so how many n plus 1s do we have? We go from 1 to n. So n, we have n plus 1s. So x, just divide by 2, right? That's this. Okay, good. So what about, let's say, well, we won't do at I is equal to 0 because that's going to be the same answer, right? What if we started at I is equal to 2? So that would be our sum. So let's do the same process. X is equal to 2 plus 3 plus 4 plus n. Okay, now put it in descending order. N plus n minus 1 plus n minus 2 plus all the way to 2, right? That's we come down to 2, not 1. Okay, now let's add these. So you've got 2x is equal to, so n plus 2. Okay, now 3 plus n minus 1 is n plus 2. 4 plus n minus 2 is n plus 2. All the way to, and at the end, you've got n plus 2. Okay? How many n plus 2s do we have? Well, not n, right? Because we start at 2. So it's n minus 1. We have n minus 1 n plus 2s. So now solve for x. Divide both sides by 2. Okay, so it is different if you start at 2. Okay, but you can see how you could figure this out on your own, or you could Google it, right? And so Google it and find out what the property is for a different index, a different starting index. And then in the next video, we're going to show how you could really take some, like you could have I cubed minus that summation. Okay, you know, that's pretty complicated, right? And you can use these properties to solve for this, right? So you could see how you might have a sequence in real life or at your job or whatever, and you might be able to take these properties and simplify it. Okay, I even on my own, I tried this at I is equal to -1, and I got the exact same answer as this. And then thinking about it, it is going to be the same answer because this is starting at 2. So you're missing a 1, right? You take off the 1 in the front. Well, that's what you're doing at starting at I equals -1. It's the sum. You pretty much take the sum with this sum with the 1 in it, but now with the -1 you remove the 1, so you get the same answer. And then I'm assuming like this to derive this, you use the technique for the summation of for getting the partial sum of a geometric series. We have or geometric sequence. We did that in the geometric sequence video. But in the next video, we're going to do a bunch of examples on how to simplify summations like this using these properties.